Hey guys, um, it's that guy. I'm back with another tutorial thing. I've been giving it a lot of thought, and I think that we'll do the same thing in every language that we can get our hands on. This week, like C++, whatever. It doesn't really matter. Um, and we'll be keeping it nice and short. As you can see, my desktop background is amazeballs. I wrote this now one evening. I ended up sitting down and just writing a little desktop background thing. In hindsight, this would have been like a much better thing to play with, but this goes into OpenGL and 3D Math, so it's not really beginner tutorial material. I apologize for the little jerkiness of the screen. My CPU is taking a beating. Also, there's a little bit of like, I don't know. I need to figure out my lighting. There's so much going wrong with lighting. Why is Blender still up? Why won't Blender go away? As you can see, I was busy making videos. This got changes. I was busy making. Oh, I think Blender's gone. I was busy making a video for my other channel where we drive around, and my family and we make videos and explore the country and explore the city and explore wherever. So anyways, onto the video. Just before that, I want to show you guys. I made a repository for the previous series. So the JavaScript series is here. It's github.com/ how to coding the programs with a Z / JavaScript. So you can just, I'll add a link to this repository or this profile or whatever everywhere. So you can see there's two commits here. There's a commit in CPP and a commit in JavaScript. Let's just eyeball the CPP. Oh shoot, the CPP is a repository that I've created that contains the source code for this thing. So what do we do? I'll spend some time. I'll rename these repositories. I want everyone to have access to this thing that like does Win32, OpenGL, whatever. But I don't believe this is something that we really want to go into too much detail on this channel or at this point in time. So I think before we do anything else, let's start off by, oh, this is actually the thing. Let's start off with a fresh window, right? Yes, I'm using Visual Studio 2017. You can go download this yourself. I need to rename that repository. Okay, so file, new project. So basically the idea is that we're going to do each and everything in like every language we can get our hands on. I was supposed to prep a little bit because in my mind, let me just check something. Oh no, I don't have a Java compiler installed. I kind of feel like it would have been easier or better to do this one in Java because we did JavaScript, we can do Java, then we do C, C++. What other languages do we have? Game, because Game is such a wonderful language. What do you got? Windows Universal. These are UWP, Universal Windows Platform apps. Those are a little bit more tricky to work with. You got Visual C++, Visual Basic, JavaScript. What's the other project tab? Solutions. What you got online? Visual F Sharp. I've never used this language. I feel like a kid in a I feel like a kid in a pet store. What is this? Hosted in WPF. Okay, now let's just be very straightforward. Let's just do install Visual C++, Windows Desktop, desktop application. I want to change this to like the repositories. Yes, how to coding .1 repo cpp javascript. I need to rename this. Okay, so first thing I'd like to do is just rename this to Cloudy, because the thing that's filled with stars is called Cloudy. I'm just going to rename that on GitHub as well, and then this is CPP. And then on here, I want to rename this repository. So how do you rename this repository? Settings. Assume it's just going to be in settings somewhere. So CPP, let's just call this Cloudy. The name is available. Template repository. Rename. And that's how we renamed the repository. So now the CPP repository, which I should edit. I should really edit this thing and say Cloudy, right? And then just commit all changes, updated readme, updated the readme, read my readme file, right? Great. Commit directly to master. Yes, I commit directly to master. You create a branch and create a pull request for me. I think I've set this repository up to have the default security, which says, you know, don't let people stuff up the master branch. So there we go. Create a Windows project 1. We'll just do it cpp blocks. To not create a directory for the solution, create it directly in the cpp folder. Don't create a new repository, solution name, blah blah blah. You see, ideally there would be more settings here on this screen that would allow you to change the defaults of Visual Studio, right? There are none such things. Okay, so you can see there's a bunch of stuff happening. I do like little throwaway projects and things. For this specific project, I think I want to use Win32. I want to, like, I don't know, create a dub section, or actually no. Let's be weird, right? Let's do like full-on GDI. Oh, I'm not wearing my ring. Why am I not wearing my ring? Guys, I'm married. I took this off earlier because I was washing my hands. Here we go. Yes, subtle brag about being married. Let's do full-on GDI. So here's a lot to go through. I think I'll go through this with you for like a couple of seconds, and then a header file, open document CPP blocks. Okay, so in the Windows world, you've got a bunch of garbage. I mean, this was skrikwekkend. This was mind-numbingly boring for me to get through the first time when I just started several years ago. Started doing Windows Win32 coding. So let's just blast through it. So what happens is the entry point to a Win32 program that is not. That's weird. Yeah, that is not. You've got different types of programs. You've got console programs, which they look like this, right? You type some garbage here, and it spits out some output here on the console. And these things, they entry points. The thing the operating system calls when you double click on it, when it starts up the program and says, "Hey, give me something to run," right? The entry point for that is always called main, right? It's the main function. It's it looks I think it's like int main, and then it takes like a pointer to like a bunch of characters, that is the arguments, and then it's the one of the arguments is a number of arguments, right? And then that is the entry point to your program. So everything starts off there, and everything compiles and runs based on that main function. You can define your own other functions and call them from there, and you can define classes and things and call them from there, and you can spawn threads, you can do whatever you want, right? But in the Win32 world, where you're saying, okay, I would like this thing to produce a window that lives on the desktop, your entry point becomes WinMain. And if you are using the wide string version of the program, which you can see here by wchar. It's just pointed to wide char. There, wchar underscore t. It's a 16-bit Unicode character. If you're using the wide string version of Windows of this program, then it becomes wwinmain. The w is just a prefix. It means wide, or like for the wide strings, for the wide chars. If you don't want wide strings and you want your code to be a lot easier to work with, you can go fiddle with the settings. So you right click on this thing, you say, you know, set properties, and you can change this to not use Unicode. You can say use multi-byte character set, which is just standard ASCII, right? There was a way to say I want to change my main, like my main, my entry point name. I don't know where this is. It's in here somewhere. If you find it, great. If you don't find it, well, tough. But there's definitely a way to say I want 3 wchrt. We're gonna just fiddle with this a little bit. So no, we don't want wchrs. Precompiled headers, you can just leave the defaults to like precompiled headers, whatever. Just want to check all of this weirdness here. Useful parts, yes, all options, and then it gives like a whole bunch of garbage. You can always sit and fiddle with this on your own. You can Google it. You can literally just look it up. I'm not too interested in that. Suppress startup banner is something useful. There's always this little startup garbage that shows when your program starts. If you don't set this to yes, then a command prompt window launches and it says that made with Visual Studio for some stupid reason. Like, just why Microsoft? Just this is only a feature of your compiler. Your compiler does this. Just take this out. Take this garbage out. It's like it's 2020. This thing is like mature for over 10 years. Just take it out. Just I shouldn't have to like put this in. Like, GCC doesn't do that. Why does GCC not do that? Why do you do? I'm ranting. It's like I'm ranting. Just maybe. So I just want to go through this a little bit to see that everything looks okay. So debugging looks fine. Yeah, you can see if you change the subsystem to console, then your entry point becomes main. If you change the subsystem to Windows, your entry point becomes winmain, which makes sense because it takes different command line different arguments based on how Windows works. So we'll dive into that a little bit more. Optimization, there's a bunch of different options for it. So I'm not gonna fiddle too much with this. Let's just say okay, and then I would like to say char. Just want to make sure that all of this works. So the load string A should work fine. So I'm just taking off all that little W's and things. So wherever it says, wherever it's using a wide string version of something, I will change it to not use a wide string version of something, except for this winmain. This is defined somewhere in the oh shoot, what did I do? I pressed some shortcut now. Control C. Yeah, I pressed some shortcut key. This thing is defined somewhere in the middle of nowhere. I'd like this to be winmain. Let's see if I didn't destroy it now. So you can see there's a bunch of errors. Is it window class alt? Is it w class x? Make int resource. Everything's got a w in front of it. It's just annoying because it's using the w means wide, the wide version of it. So instead of being 8 bits per char, it's now 16 bits per character. It's wider in terms of the amount of resource it uses. But it also means that every single flipping function that is called as create window w, this you could have just called create window. It's I can show you this. Create window, if you're using Unicode, create window is defined as create window w, which is a function that takes wide strings. Else, if you're not using Unicode, then create window is going to call create window a for ASCII or ANSI, whatever you want to call it, right? So why in the flip with the default template use the W version of it? There's no reason. There's no reason to do it. So basically, let's start at the beginning. Winmain is called and there's an instance passed to it, right? the handle to an instance is passed into it. Everything that's got an h in front of it is h is for handle, right? So handle to instance, handle to wnd. Wnd means window, right? um got orchestra. So this instance is the handle to your current instance that you are creating. The optional thing is the handle to the previous instance that existed before, that's calling this code. So usually you don't mess with that, you don't touch it. The this alpestra is a pointer to a string, which is the command line that's passed in. So if you call this thing from here, let me just show you something. So if you do like explorer dot, this is a window program, right, which opens a explorer window, right? If you do that, these commands are passed in there, and that command expands to current folder. So it would call explorer.exe and then this massive path to it. That's that. And in this in cmd show, I cannot remember. I'm assuming that cmd show is hide or show, right? Let's see what init instance does. Yep, show window in cmd show. That's either show or hide. So you can start a window hidden and you can start it visible. You can control this from outside if the program is written to support that. As you can see, Windows itself supports starting windows or windowed programs in hidden, because Windows thinks underneath. So you can do things like this and pass in like hidden, and that'll just start the window hidden. It's super useful. Sorry, let me just pop out here. It's super useful for things like, sorry about that, it's super useful for things like writing little driver mode programs or little windows that hide themselves in the middle of nowhere. They can start themselves up in a hidden way that allows you to uh, put stuff here in the tray that allows you to interact with the window, but it doesn't clutter up your taskbar. So that's just the entry point. You can see there's a whole bunch of garbage going on. There's about and whatever. I'm not going to strip anything out yet. We'll clean it up later. But there's this unreferenced parameter thing. It just expands to brackets and that. Let's just see. F12. What does that do? Yes, it just expands to brackets around this thing. It's just a way to tell the compiler, ignore that I'm not using this thing. It mentions this so that the compiler says, oh, it's referenced somewhere, right? To do place code here. I will do. This just loads the strings from the resource file with these resource identifiers, IDS title and IDC CPP blocks. This is the title of the window and the class name of the window, right? It loads this out of the executable resource file and then sticks them into these little global variables, right? Is there a reason this is? Oh, the reason is that you don't have to pass it in here. So that just loads it out of the executable resource file and sticks them into these little arrays that hold chars and things. Yeah, so it sticks them into there. This max load string is 100, and it means you can load 100 characters into this thing called SA title. So SA title is just a chunk of memory that gets reserved in the global scope of the program. We haven't touched on scope yet. I guess I'll do a beginner series where we touch on scoping and all that kind of jazz. Right now we're doing the tango. We need to go back and do the jazz. Right? You need to do a little very tight box step to get up to this point. But for now, if you know what scope is, if you at this point where you know what else is going on and you want to do a win main function, you can do it. Yeah, you know what these things are. This is an input, this is an optional input, but you need to declare it, otherwise your function isn't going to be called properly and your thing won't compile. And you got a string that is command line, and this is ncmd show, which is just whether it should be visible or hidden when the window starts up. It's an int. It returns an integer, and this API entry thing, I think it's just the call type. Std call is, yeah. So you've got std call, cdecl, and you've got fast call. I don't think we ever use fast call here. We only use fast call when we're dealing with assembly. So std call is just determines huh, it fiddles with the function semantics. Well, I'll go research. I'll go read that a little bit, and then I'll come back and explain it to you. I can't say it succinctly. I have like this little model in my head, but it's gonna take too long to put it in words. So let's just jump over. We got a myRegister class. This is a function that's declared here, that exists here, and all you're doing is you're creating a window class, and all this says to Windows is this window class is actually something interesting that happens. You tell Windows about your window by creating this window class structure, right? And in there you define certain aspects about all the windows that you create using this class. You can create multiple windows with this one class. We'll dive in there, but for now you can just bear in mind you can create multiple windows of the same type. That's how these multiple document interfaces work. If I can just show you, if you look at this window pretends to be a multiple document interface. So you've got these multiple little bits and pieces that you can move around here. They're part of this window, but they're not really part of this window. They inside this window, they're not outside, they're inside. So these things are little extra windows, and they all share some behavior. So you would have created the builders of this program would have created a type of window class that describes these little tool windows, and they would have just like spammed a bunch of these, like register one class and describe what goes on in here, parts of win procedure in here, blah blah blah, and just spammed a bunch of create window with that specific class. I think that's about right. Yeah. So you create this thing, you tell it I want to redraw horizontally and redraw vertically. You tell it the window procedure pointer is this winproc function, which is just a pointer to a function. We have it here, and that is just a message pump. So whenever anything happens, like your cursor moves or Windows wants to tell your program something, it passes a message into the window procedure and says to you, hey, here's this ID and here's some params with it, figure out what this means. And Windows, the Win32 API is really smart in that they give you a bunch of messages that have like these identifiers. So these identifiers, this WM destroy is 0x0002. Its mnemonic is WM destroy. So WM stands for window message, and destroy is like, hey, you're all getting destroyed now, you're all getting wrecked, this window is getting taken down, boy. So when you get past this message, usually in response to one of these close button clicks or like Alt F4, you get past this post quit message, and the post quit message is received in your message pump, and it just like dumps you out of this loop. This get message returns false once you post your quit message. This get message returns false and dumps you out of the program. So we'll get to this. So we're registering this class, we're telling everyone to draw horizontally, vertically. Here's this window procedure that handles these messages for us that Windows sends to us. The instance that we're registering this window class for is this instance that was created automatically by the operating system for us and passed in. This instance is us. It's our instance. It is who we are. We are an instance of this program. This is our instance handle. We don't really care too much what's in there, but we do know that Windows uses certain functions. Like if you want to say, I need to get the path to this program, there's no way to say in here like this program. What does this mean? There's no like this. That doesn't mean anything at this level. This is all global scope. So the way you say or reference this program is with this instance handle. So you could say get module file name, and then you pass in this handle, and Windows says, oh, this instance I started lives at this location. It's based on your command line, and then it passes that back to you. So this instance is important. It's a way for the operating system to understand that this program running in this scope is this specific thing it started up and then it passes that information inside WinMain and says, this is you. This is who you are, right? This first parameter is this is who you are. This is the other guy who started you up, and this is your command line parameters and whether you should show or hide. But this very first thing is this is you. This is your instance handle. So you tell Windows, like, for this instance of program, I'm registering this class of Windows. You load up an icon. Let's just make int resource is it takes some value out of the resource file, and it's just an ID. This making resource function, just I think it makes it a wide ID. Making resource w, yeah, it just makes it a string. It takes that ID and it makes it a string. It's like a one char string. It doesn't make any sense. Anyway, that does make int resource. It's just like a foolproof way of getting this icon in there. Same thing with cursor. You can specify I want a hand cursor or whatever. Let's just see if we can go change that. Up, IDC hand, right? I'm assuming we can use IDC hand here. Let's see if we can just change this cursor to IDC hand. So we'll get that little browser hand wherever we, whenever we move over this this window area on the screen. The brush is just whichever brush color you want, +1. So if you want the color of the window brush, which is defined in your, on the old Win98 systems, you used to have this little dialog box. You'd say desktop properties, and then you'd go to perform color scheme, and then it would give you a little dialog box with all the little colors that you can say the color of the window is whatever, and you could then go and tweak the way your desktop looks. So if you wanted to create a theme, like a purple theme or a dark theme or whatever, you'd go and tweak those little window settings and then export that file and then send it to people, and they would import that file. That's how the old Win98 and WinXP themes used to work. These things still exist, these colors still exist. So let's go see. Color button, color dialog, color message box, color edit, color static, color max, color background. I want to have like a black color. Can't I say HBR background is, oh, you know, this is the introduction. I'm already doing get stock object black brush. There's these stock brushes that Windows has that you can say, you know, I would like my background brush to be the black brush. That's all we're saying here. You have to cast it because get stock object returns a handle to a GDI object. And this thing is, the type of this thing is H brush, and the type of that thing is HGDI OBJ. So to get these things to match up on the compiler to not complain, you have to cast it by telling it, hey, you know, this is actually a that thing. It's literally what that is saying there. It's like this get stock object function, even though it says it returns this thing, actually it's a that thing. That's all it's doing. Menu name is some menu name. This Visual Studio by default generates you a little fake menu with an about box in it and an exit menu option. Finally, the class name is this AZ window class that we loaded in here into this variable, this array. We're passing it in there now, and we're saying, hey, this is the class name, and then we've got this tiny icon thing that sits here, and we've registered the class. So once we've registered the class, Windows now knows that whenever you talk about something and you say, hey, you know, I want to window, here's my class name, my window class name, it knows that that window class name actually refers to this little thing here with all these properties in it, and these icons and cursors and brushes and whatever. So you are now associating all these properties, right, with whatever name is in this array. That's all that does. That's all that register class does. You fill in this thing and you say, you know, I'd like to associate all these properties and behaviors with this name. So whenever you say I'd like a window and here's the name of the window class, it knows that these properties exist. It knows how to map these properties onto that window it creates for you. So now I got this little window set up. The next thing it calls here, we're just going in order. It goes through init instance. If it could not init instance, it returns false. It means something went horribly wrong. Let's just go through init instance. It's very straightforward. You're saying, hey, Windows, create me a window. And here's the window class name and the title of the window. The type of the window is overlapped, which means it's got a, if you can see this thing, it's an overlap window with a caption, a system menu, a thick frame, a minimize box, a maximize box, right? So it means it's got a resizable border. I think it's a resizable border on it, like an edge that you can grab to resize. It's got a system menu. System menu is one of these things, right? It's got a, yeah, thick frame is resizable. It's got a minimize box and a maximize box, which are these things, minimize and maximize, right? And I believe that by default, the thick frame windows get a little close icon as well. I didn't see it here, but I think it's in here somewhere. In one of these overlapped or thick frame has a close box in it by default. CW is default, CW is default. So what that means is this create window function takes a window class name, create a window according to this window class that we associated with a bunch of these properties, right? The title that must be displayed on the top here, the window styles, like the window styles, not the class styles. These class styles are CS class styles and WS are window styles. So these class styles are global. Any window that's created with this window class name get all these same styles applied, but you can control each window individually. So you can say this is an overlapped window, you could say this is a pop-up window, you can do a bunch of stuff. This, I believe, is an X coordinate, a Y coordinate, a width, and a height. So I want to make my X coordinate 100 pixels from the top left of the desktop. My Y is also going to be 100 pixels, and my width is going to be 400 pixels, and my height is going to be 400 pixels. We'll see now if that actually does the thing. It's got a bunch of null pointers. We'll jump into the null pointers, but for the most part, usually this is all you would actually need to create the window. So create window, it's got a class name, a window name, a style, and X, Y, width, height. So you can see here, create window A. This is the one it resolves to. It's got the class name, the window style, the X and Y coordinate, the width and the height. It's got the parent window. So things like buttons and things, the parent window of this little button is this main window, or this menu bar window, right? This toolbar window. The parent of this toolbar window is this main window area. So you can specify that these things belong to these other things. Handle to a menu, which is one of these things, right? Or menu bar. An instance, right? So you can pass in the instance that you were given here. So yeah, and an alparam. So an alparam is just a creation parameter that says this window knows something about itself, and that alparam can. It's the same as when you spawn a thread. So it's just a way to say this window knows something about itself, and this alparam is something different. So you could create this thing. You could have a thing called like image button, and you can have an array of images, and this alparam would be index into that array, and you could then pass it in and create these things in a loop, and each one gets an index into the array, into the image array, and when they render using that alparam, which is an index into the image array. So these images show up in order as you specify. So you can use it like that. If the window creation failed, this create window will return either a handle to a window or false. So if it's returned false, the definition for false I think is just 0. If it returns false, then you return false. You have to say, well, I couldn't init this instance. But if it didn't, you fall through and you say show window with that in command show, which is usually just SW show if you wanted to show, and then update the window. Update the window just calls this first paint cycle. It just causes this WM paint to be called, right? WM paint is just a way to draw the window over and over. So now we've got enough information to understand that we now have a window on the screen. So here's an accelerators table. So accelerators are things like if I hit this keyboard button Alt F, right? There's a bunch of little mnemonics here, so you can do I can actually show you this. If you want to do this, Control Shift N, that's an accelerator. That's a keyboard accelerator. It means the reason it's called an accelerator is because it is, if you have your hands on the keyboard and you're busy typing, it is faster to hit a key shortcut combo than it is to actually drag the mouse across this entire vast barren desert landscape of desktop out of the world of nothingness here into this tiny little sliver of like civilization, and then hunt and pick through the menu, right? Because if you miss the option, you have to go back. So you have to hunt and pick through this menu and then hit this tiny little rectangle that is like literally 1/20th of the height of your window, right? So it's incredibly slow to go and hunt and pick, right? This is like the slowest part of operating Windows is the mouse. But if you want to do something, you can do something like that. Now you use an accelerator and you just do whatever, right? So you load these accelerators because you can go and define your own accelerators inside your application. I'll show you the resource file now. It just creates a table, an H-axle table, and that table you can then use to try and translate the accelerator, and Windows would then take that accelerator and say, well, when they hit Control Shift something, they were actually trying to trigger like this thing, right? For instance, you could just it's a command. It shows it passes your command message, but it expands it into its constituent parts for you. So you load up the accelerators and then you enter into this like message pump thing. You say, get me a message from the Windows message pump. It's like a buffer that holds a bunch of messages in order that Windows is trying to pass to you. Get it into this message object. There's a bunch of parameters for this. I don't know what these are. I'll go check these. But get this message. If you can't translate this accelerator for me, because if an accelerator is translated, this function returns true and doesn't do this. It actually just bypasses your whole thing and spits out a WM command message for you on your WinProc, right? It'll translate that accelerator for you. If it couldn't translate it, you'll just say, well, translate this message to something. Windows will do whatever. And then dispatch message passes the message out of your get message, which is talking to Windows directly, into dispatch message, which is pass it along onto your message loop, right? So this processes message for the main window. This WinProc thing gets called like hundreds of times throughout the lifetime, or thousands of times throughout the lifetime of your program. It is a way for Windows not only to communicate with your program, but for you to communicate with your program as well. You can trigger messages. You can say, oh, like, post message to my message pump, and the message type is WM command, and the command is IDM about, and then it will just like flip and spit out this dialog box thing for you. And the dialog box has its own message pump. So this is the guts of what we're going to be working with. So wherever you see all this, does this even compile? I fiddled with the project settings before I did anything else. Maybe it doesn't compile. I remember I changed the main function name. Maybe that's defined somewhere in the code. Let's see if it actually does anything. So, oh, it succeeded. Oh, let's run it. So that is the guts of a window. So this is step one, is just get a flipping window on the screen. Microsoft Visual Studio is made. Oh, see, black. Get stop object black, and we got a hand thing. So I can show you where this black and this hand thing comes from. If we change this, let's just take off get stock object, right? So you do color window, I think you do +1 to make Windows understand what you're doing, and then you change your cursor type. What was this? IDC arrow, I think, was the default, and then you just, where's my debugging bar? Oh, there we go. Oh, I changed the order of these menu items. I'm used to this being here, there, where I can see it. So if you just rerun that, the color of the window would have changed, and the cursor that shows on the window would be this arrow thing that you can see here, right? The first thing I did before I even showed, there we go, the color of the background has changed. This thing here inside is called the client area, and this cursor you can see in this text area here behind it, where we can type text. It's a carrot. I usually call this a carrot because it's not spelled the same as a vegetable. It's a carrot. Sorry, it's raining. But over here, we've told Windows, whenever you interact with this window, I would like to have this arrow for the mouse. That's actually really cool. This is how browsers also get that little hand icon when you're about to click on a hyperlink. You can change this on the fly. So I just want that to be a hand, and I'd like this to be color window. I'd like this to be a black brush. I'll just go fetch a stock object. Windows has a bunch of these brushes things that you can go and use at any point. There's all not all of them are the brushes. You got a white brush, a light gray brush, a gray brush, a dark gray brush, a black brush, and a null brush. I believe black and null brush are the same. No, sorry, hollow brush and null brush are the same. It means don't draw. But I want a black brush. I want to actually draw in black. There's a bunch of stock pens as well. You got a white pen, a black pen, and a null pen. You got OEM fonts, ANSI fonts, system fonts. You got device default fonts. You got system palettes, and you got system fix fonts. You got a whole bunch of like weird things that Windows can give you on its own. The Win32 GDI is massive because it's what we used way back in the day to build everything. But right now we have this window on the screen. So I think before, yeah, I'm nearly done. But one of the things, the interesting things I want to show you is that here's this menu name thing, right? This IDC CPP blocks. It defines this thing. It says there's a file with exit and there's help with about. So let's just go find that thing quickly. You've got this resource source.h, and this thing's got IDD about, IDM about, IDM exit. So these IDM, ID, and this M says menu. So it's ID for a menu item about, ID for a menu item exit. And these correspond directly with this. This is the exit, IDM exit, and this is the about, IDM about. But these are just resource identifiers. These don't actually mean anything, because I can just go and define something. I can say hash define blah and then give it like a whatever. It doesn't actually mean anything on its own. The way this works is that you define these little identifier things that mean these things to my program, right? And then you go inside the resource file. Just open with the code editor. I don't want to open it in that design view. It's this resource editor now. I want to open it with the source code editor. This resource file has a bunch of macros in it that mean something to Visual Studio, right? These hash defines and whatever. But here you can define, this is my menu. This is how you define a resource in Windows. This is how you fiddle with the menu. You can say, I've got this thing, it is my menu. The beginning of the menu is a pop-up with the text file on it, right? And the accelerator is &f. So what that &f is, if you say Alt F, right, that ampersand means Alt, and the thing following it is the keyboard, the keyboard key that you want to trigger that. So anytime you hit Alt, it means you're trying to accelerate into this menu, and the thing that follows this ampersand, this F here, is the thing you're accelerating towards. So if you do &h or &a, it should be let's do this. So Alt A, nope. Alt A, nope. Oh, I'm jumping too far in. This is the top level accelerator. So to trigger the menu, you do Alt F. So let's try and trigger this menu, which would be Alt H. What that means is, if we then do Alt A, we'd be able to trigger this about menu without using the mouse. So let's try Alt H and then Alt A. No, Alt H and then A. There we go. Okay, so the first time you trigger this Alt here, if you do this Alt H, it locks internally. It locks that Alt as you are in a menu, and then whatever you in the sub menu that you trigger and say, oh, I want to do something, it is this A key is now marked as an accelerator. I'm just curious, like, here's more accelerators that makes it even shorter. So you can use the menu system to accelerate your way into it, or you can use these accelerators. So let's see this load accelerators. Let's see if that is what we want. So okay, so what is it? Alt question, yep, alt question mark does it. So you can define this. So you could make alt slash is also. So let's do alt slash. Yep, it triggers this little menu. So this is how you accelerate into a program. This is how you define these cool shortcuts. This is, Microsoft Word has like 4 pages of this garbage in it, and this menu is just a nightmare. In fact, they've moved away from this. They are now using a something called a ribbon, which is, it's just as horrible, but you don't have to do like 50 pages of this anymore. So let's fiddle with this before we go anywhere. So let's just call something. Let's say not help, right? So &n should get me in there, and then meh about, right? So Alt N should get me in there, and then hitting the M key should trigger the about. Let's see. So Alt N and then an M. That should get me in there with that about box. If I do Alt N and then M, there you go. So we have now just gone and defined our own menu item. Let me just show you how this works. we'll just say IDM about. We'll just copy this message, right? 104, 105, 609. We'll just stick our message at the end here. I'll show you what this does. 109. Yeah, you gotta change this next sum ed value to 111 because we're no longer using 109, we're using 110 here. This just keeps track internally. If you use the editor, if you don't update this, the editor gets confused. It's like this editor view where you can change the layout of your windows, you can define pop-up menus and things. But if you don't change these things, it gets confused. So I'll just call this not about. Right, so now I've defined here's this thing called not about, right? Control C, Control S. I want to now go into this resource file and say, when I do this not help me about thing, the resource value that's tied to that ID that I define is this thing. So when it passes that to the Windows message pump via the WindProc, when it passes it in there, it becomes a WM command message with this value tied to it, and the value I want tied to it is this IDM not about, which means 110 in decimal. So actually, hold on, 104. What did I do here? 109. Oh shoot, that's my bad. I want that to be 110. See, if you mess with it, it messes back. So now you'll see in the code there's this IDM about. So the low word of WPRAM, the first 8 bytes. WPRAM is an unsigned int. It's 32 bits long. So the low word would be 16 bits long. So the first 16 bits of this WPRAM message thing is what gets passed. That accelerator ID gets passed in there, that menu item ID that we associated in the resource file, that is 110. It gets passed in here. So you can actually say if you switch this IDs, because you know that if I receive 104, spit out this dialog box. Else if I receive this, whatever this value is, it's like resource.h, exit is 105. If I receive 105 here in my message pump as a WM command, spit out destroy window. Destroy window just causes this WM destroy to be sent on the message pump. You can then post quit message from there, which causes get message to return false, right? Which spits you out of your WinMain. WinMain is a blocking function. It sits in this while loop constantly. Get message blocks. So if there's no message to get, it just sits there waiting until a message comes back. It spins. It just sits there busy until it has a message. So this thing blocks and stays in this loop. And once post quit message is passed in, it causes this get message function to return false, which then dumps you out of this window. That's all it does, right? So this WPRAM that gets passed into this message here as the final thing is actually I believe this value here. We can test this if I just do 1. No, let's do something asinine like 2667 and then just pause here to make sure that this WPRAM that gets passed in is actually what I'm saying it is. We'll have to compile that thing and then get it to run. But I was still showing you if I do this and I tell Windows, oh, I'm not looking for this about resource identifier, I'm looking for this. I undid the not about typing I did there. That's weird. So if I call it this not about thing, yeah, and I tell Windows, oh, I'm interested in actually seeing this value, this 110. Obviously when I get it, I'm just gonna spit out the about box because why not? But I'm interested in seeing that value. Then when I do this, when we trigger that menu item, instead of it triggering based on this IDM about, we've now made it trigger based on our own menu item, and this gives us the ability to define things. So I do Alt N and then M. It still does a dialog box. I'm curious if I do that. This WM param, 2667. So as you can see, when you post a quit message, you can quit from different spots in your program and just post a quit message from wherever, and it will get passed along here. So you can then examine this output and say, well, my program quit abnormally because it's not a 0, or my program quit normally because that value is 0. So obviously we want to signify that the program quit normally, but if this were under exceptional circumstances, due to throwing an exception somewhere in the code, you could then pass a numerical identifier in there to help you track down what caused the exception and then go and remedy that. So as a step 1, we've now got a window on the screen. We've seen a little bit how menus work. There's multiple ways to get the menus up and running. You can use the Visual C++ resource editor to do it. I hate that thing. Usually when I create windows, I create them as pop-up windows. We have a way to modify the cursor on the screen to tell Windows whenever the mouse is on this window, this client area, this black bar, it needs to be this little hand cursor thing, and we have a way to tell it I'd like these menu items on the screen. So I think I'm going to use these menu items to have like a new game, restart game, pause, whatever option, and then we'll use the accelerators like what was it, alt question mark. We'll use these accelerators to trigger game events. So we'd have little shortcuts on the screen that we tell you, like instead of using only clicks, the way the JavaScript one worked, we could actually take advantage of a little piece of the Windows methodology and say, you know, we'd have menu items and keyboard shortcuts that perform certain functions. And I think that's it for now. I'm super happy with this. I'll go stick this on the GitHub and then everyone can follow along. But I'm super happy with how this came out in only like flipping hour. We've got a blank window on the screen using code that Visual Studio spat out for us. But now we at least understand what all these things do, right? So next time we come in here, we'll start examining these little bits and pieces here and start doing like, hey, let's draw a paddle on the screen, right? Because that paddle, I'm so excited about that paddle. Okay, so everyone stay safe. Thanks for watching. Thanks for joining. Have a good one.